Good morning to all. Myself Dr. J.Jayapal, Assistant Professor, PG and Research Department of Computer Science, St.Joseph College of Arts and Science, Autonomous, Cuddalore. The subject computer architecture. Okay, now we are going to see the pipeline and vector processing. The heading is parallel processing. The parallel processing is a term used to denote a large classes of techniques that are used to provide simultaneous data processing tasks for the purpose of increasing the computational speed of computer system. A parallel processing system is able to perform concurrent data processing to achieve faster execution time. Okay, throughput. The purpose of parallel processing is to speed up the computer processing capability and increases its throughput. That is, the amount of processing that can be accomplished during a given interval of time. So this diagram, it is representing the process with multiple functional units. One possible way of separating the execution unit into 8 functional units operating in parallel. So here the diagram is representing the to memory is bidirectionally connected to the processor register. The processor register is connected to the so many operations in parallel: adder, subtractor, integer multiplier, logic unit, shift unit, incrementer, floating point add subtractor, floating point multiply, floating point divide. So all the processes parallelly connected to the processor. The operation performed in each functional unit is indicated in each block of the diagram. The adder and integer multiplier perform the arithmetic operations with the integer numbers. The floating point operations are separated into 3 circuits operating in parallel. The logic, shift and the increment operation can be performed concurrently on different data. All units are independent of each other. So one number can be shifted while another number is being incremented. The Flyn's classification. It is the combination of instructions stream and data stream. Here the functional stream. It is the combination of instruction. A read from memory is called the instruction stream. The data stream, the operation performed on data in the processor is called the data stream. Here, the Flyn's classification groups divided into the computer the 4 major groups. They are SISD, single instruction stream, single data stream. Second, SIMD, single instruction stream, multiple data stream. And then MISD, multiple instruction stream, single data stream. And MIMD, multiple instruction stream, multiple data stream. The SISD represent the organization of a single computer containing a control unit, a processor unit and a memory unit. The SIMD, single instruction stream, multiple data stream. It is represent an organization that includes many processing units under the supervision of a common control unit. All processor receives the same instruction from the control unit but operate on different items of data. And next one is a MIMD, The memmed organization refers to a computer system capable of processing several programs at the same time. The most multiprocessor and multi-computer system can be classified in this category. And memmed. The next one is meshed. This structure is only of theoretical interest since no practical system has been considered using this organization. Supercomputers. A commercial computer with vector instruction and a pipeline floating point arithmetic operation is referred as a supercomputers. The supercomputers are very powerful because high performance machines are used for computation. The components are paired tightly together. It uses a parallel processing. The applications of parallel processing. The application of parallel processing are numerical weather forecasting, computational aerodynamics, finite element analysis, a remote sensing application, genetic engineering, computer-assisted tomography, and a weapon research and defense. So, the parallel processing you have to classify it into the following topics. The one is pipeline processing, second vector processing, and third one is array processor. Types of processing. Pipeline processing. Pipeline processing as an implementation techniques where arithmetic, suboperation, or phases of the computer instruction cycle overlap in execution. Vector processing. Vector processing deals with the computation involving large vector and matrices. Array processor. An array processor performs computation on large arrays of data. After we will see one by one the pipelining process and vector processing and then array processing. First, pipelining. Pipelining is a technique of decomposing a sequential process into sub-operation with each sub-process being executed in a special dedicated segments that operates concurrently with all other segments. The pipeline can be visualized as a collection of processing segments through which binary information follow. Each segment performs partial processing by the way in the task is partitioned. The result obtained from the computation in each segment is transferred to the next segment in the pipeline. So the final result is obtained after the data have passed through all segments. The pipeline organization will demonstrate by means of a simple example. A into B plus C for I is equal to 1, 2, 3 up to 7. Now, the A of I is assigned to the R1 register and then B of N is assigned to the R2 register. These are the input, and then C of N is assigned to R3 and D of N is assigned to R4. So these are the input, and then A of N is assigned to R5. Now A of N into B of N is assigned to the R5, and C and D multiplication assigned to R6. Finally, the R5 plus R6 is a resultant value is stored into the R7 registers. Here, so that is the diagram. It is representing the pipeline processing, the A of I, B of I, and then C of I. The A of I is assigned to the R1 register. the B of I value is assigned to the R2 registers in the segment 1. The R1 in R2 multiplied by the expressions, and the multiplier, it multiply the R1 into R2, that resultant it will be stored into the R3 registers. In parallelly, the C of I is, it is entering into the R4 registers in segment 2. Here the R3 and R4, the two registers added by the adder, that resultant it will be stored into the R5 register. The R5 is the segment 3. So these are the flow chart, and then on tabular column, it is a content of registers in pipeline. The first one is a clock pulse numbers. The segment 1, R1, R2 register in the segment 1, R3, R4 the segment 2, the R5 register in the segment 3. Now the first clock cycle, the segment 1, the R1, R2, it is entered into the first segment, but the segment 2 is there is no any data, and also the segment 3 also there is any data in first clock cycle. The second clock cycle, the new data entered into the R1, R2. The second clock cycle, the segment 1, the previous segment, the A1, B1 is transferred to the segment 2, R3, and then new data entered into the R4, that is a C of I. The segment 3 is, there is no data in the segment 3. And third clock cycle, the new data entered into the segment 1, that is A of 3 and then B of 3. The A2, B2 is transferred to the segment 2, A2 into B2 and C2. Now the segment 3, the new data entered in the third clock cycle, A1 into B1 plus C1. Likewise, the data is entered into the segment 1 and segment 2, segment 3, up to the I is equal to now 1, and then 2 incremented 2, and then incremented 1 by 3, and then the I value is 4, and then I value is 5, I value is 6. Now the finally the I value is 7. The first segment 1, the seventh data is entered into the segment 1, that is a R1, R2. Now the segment 2 is the A6 into B6, C6. The segment 3, A5 into B5 plus C5. And then the I is entered 1 to 7. The segment 1 is, there is no any data entered into the segment 1. Now the segment 2 is A6, A7, B7 and C7. The segment 3 is the A6, B6 plus C6. And then 8th clock cycle, there is no any data in the segment 1. Likewise, the 9th clock cycle, there is no any data in segment 1, and then segment 2. The segment 3 is the last data is manipulated in A7 into B7 plus C of 7. So finally, we have to complete it in the 9 clock cycle pulse. We have to complete it in the 21 operations. So parallel processing means we have to minimizing the computational timing. Okay, general consideration, the task. A task has the total operation performed going through all the segments in the pipeline. Each segment consists of a computational circuit, the S of I, what performs a sub operation over the data stream flowing through the pipe. The segments are separated by registers Ri that holds the intermediate results between the stages. The information flow between adjacent stages under the control of common clock applied to all the registers simultaneously. The next one is arithmetic pipelining. The arithmetic pipeline units are usually found in very high-speed computers. They are used to implement the floating point operation and second multiplication of fixed point operation. The third one is similar computer encounters in scientific problem. The inputs to the floating point adder pipelines are two normalized floating point binary numbers. So that is x is equal to a into 2 to the power of small a, y is equal to b into 2 to the power of small b, where a and b are two fractions that represent the mantisas, and small a, b are the exponents. The floating point addition and subtraction can be performed in 4 segments. The registers labeled R are placed between the segments to store intermediate result. The sub-operations that are performed in 4 segments, they are: the segment 1, compare the exponents; segment 2, align the mantisas; segment 3, add or subtract the mantisas; segment 4, normalize the result. So this is the diagram. It is representing the pipeline for floating point addition and subtraction. So that is, it is splitted by the 4 segments: segment 1 and segment 2, segment 3, and then segment 4. The small ab is the exponents, the capital AB is the mantisas. The small ab value is stored into the registers. Likewise, the mantisas AB value is stored into the R register. And segment 1, compare the exponent by subtraction. Although consider to normalized floating point numbers, we take one numerical example. So that is x is equal to 0.9504 into 10 to the power of 3, and then y is equal to 0.8200 into 10 to the power of 2. Now the two exponents are subtracted in the first segment to obtain 3 minus 2 is equal to 1. The larger exponent 3 is chosen as an exponent of the result. The next segment shift the mantisas of y to right to obtain. So what will happen? So that is the x value is the same value, the y value is, we have to change it. That is the one fractional value, that is a 0.0820 into 10 to the power of 3. So that is a 10 to the power of 3 in the segment 2. And add or subtract mantisas in the segment 3. Now we have to add the x value and then y value. We are getting the final product z value, that is a 1.0324 into 10 to the power of 3. Now we have to normalize the result. In the segment 4, z is equal to 0.10324 into 10 to the power of 4. Okay, now we are getting the normalized result. Thank you.